of sine. 99th derivative of sine. They have this kind of a problem on the AP exam. Every year there's one problem, or they'll ask you like the 88th derivative of cosine, or the 90th derivative of sine, or the 24th derivative of a parabola, which that one's really easy. Okay, but there are, for those of you who didn't know, there are higher order derivatives. There's not just a first derivative. We call it the first derivative right now. Take the derivative, call it the first derivative. But next week we're going to get into the second derivative and what the implications are there. Right now, the first derivative for you means slope. Second derivative means something else. Second derivative means something totally different. Okay, it actually talks about concavity, which we'll get into next week. First derivative means slope. Second derivative will mean something else. Third derivative kind of loses its meaning. It does have meaning. It's called, in the physics world, it's called jerk. And what you're going to learn next week is that in physics, the first derivative is velocity. The second derivative is acceleration. And the third derivative is jerk. When you get to the fourth and fifth derivative, they really start to lose their meaning. In fact, once you get to the, you're going to feel like you're in physics class for about a week. Okay, it's going to drive some of you insane. For people in physics, the light bulb is going to go off big time. You're going to be like, oh my goodness, she is hidden so much from us. And that's because she does a lot of calculus. So you'll get to see both sides of it, and it really brings everything together. For the people in physics not taking calc, they never get to see it, and they're kind of like, I don't know how this works. Okay, Cannon's not here this morning. So he's one of the people that texted me this morning. Got to sleep till 7:30 because I stayed up to 2 for science research. So, is there science research this weekend?
Yeah.
Yeah, there's big deadlines going. So I was like, I get it. Stay home. Huh?
They procrastinated to the max.
Oh, that's their fault. Sorry, Canyon, your fault. All right, f of x equals cosine x. Oh wait, sine x. All right, so here's how you do it. You start to run it through. When you do the 99th derivative, like you could literally, I've seen people do this, and it's the dumbest thing ever. They'll start taking the derivative, so they go f prime of x, and they get what? Cosine. And what you'll notice about this one is you start taking derivatives, it's going to start just to bounce back and forth between sine and cosine. But one other thing's going to change. The sign's going to change. Not the sign as in S-I-N, but the sign value, S-I-G-N value, okay? That's straight. All right, so then when you go to the second derivative, how do we denote it?
Double slash.
F double prime. That's going to be negative sine. So we're not back to sine yet. Okay? Did you see the sign? Okay, sign change? I saw the sign. Okay? F triple prime of x. Now it's going to be a negative times sine x. What is that going to be? Negative cosine. Then we go to F quadruple prime. Usually they start using Roman numerals at this point. What do you get? Back to sine. And then if you keep going through this process, you'll see that this one will just keep oscillating forever between, and the pattern takes about, how many does it take to repeat? It takes 4. So if you keep going, you'll go F5, F quintuple prime, or 5-tuple, whatever you want to call it. You're back to cosine. And then you'll just keep going through the same pattern again. What we want to do is find a 99th derivative. What's the symbol for a Roman numeral for 100? Is it M, or L, or C? I don't know. What is it? Well, L is 50. C is, let's go C. So it'd be IC. Check your grades in Infinite Campus today. X is 10. Okay, so we'll go with that. IC is 100, so IC would be 99. So what we want to do is figure out this one. What we can do is we can use the pattern. And the only person that sent in one attempt after I told you he's going to get extra credit is Max. So if he got the right answer, he's the only one to get extra credit.
You told me I got it wrong.
I didn't say anything yet. What did you say?
What did you say?
I said if you sent it to me by the end of the day on Friday last week. I only did it for one class, sorry.
Yeah, that was
Y'all got the shaft. All right, so 1 let's see, 1, 2, 3, 4, then it repeats. So the pattern is 4. So here's what you can start to do. You ready? You say 99. How many complete cycles? How many does it take to complete a cycle? 4. So every 4 it's going to complete a cycle. So all you do is you see how many times 4 goes into 99. See how many complete cycles it's going to make. How many times does 4 go into 99? Well, it can't be 25 because that'd be $1. 24 complete cycles, you guys said back there. Great. Completes 24 cycles. But now it gets into the 25th cycle. How far does it make it? 3. The remainder is the key here. This is the cycles, how much it takes to repeat. The remainder is how far it is into that cycle. It only makes it 3/4 of the way. So you go, all right, this is the start. So this is 0. 0, 1, 2, 3. Negative cosine. What'd you say it was?
Cosine.
Yeah, that's it. Negative cosine is the answer. And by the way, the first one's always 0, so the pattern goes 0, 1, 2, 3. Once you get to 4, you're back to a remainder of 0. Does that make sense? So that's how you do it. You want to try one? Or do you got it? Okay, good. All right, now let me ask you this, just real quick. What would be the fifth derivative, or the first 5 derivatives of x? Do the first 5 derivatives of x cubed minus 2x.
0.
Well, first 5 derivatives. I know it's eventually going to get to 0. All polynomials eventually get to 0, but just list off the first 5 derivatives just real quick, just to make sure. So go ahead, Colin. You can tell us. You don't have to write it down. I just want to make sure.
Squared minus 4x.
3x squared minus 4x. What would be the next one?
6x.
6x minus 4.
6.
Triple prime would be 6.
0.
And then the fifth derivative would also be 0. And then what happens at this point?
Restarts or something.
No, at this point it just does what? Stays at 0. There's no point to doing any more derivatives. Once you get to 0, you're taking more derivatives, not going to do anything. Okay? So those are called higher order derivatives. Number 19, you said? Is that a problem?
27.
Okay, well, I don't know why I thought 19. 20 what?
7.
27? All right, what does it say?
Y equals 3x plus 2 over x
3x plus 2 over x. Oh my gosh, I know which one you're going to do.
Times
times the
times.
x to the negative 5.
Oh god, here we go. X to the negative 5. Times what?
Plus
Plus 1.
We could do 28 too. That's what you
1. 28.
Oh. Okay, you got to make a decision here. If you do not simplify before you do this problem, you're going to have to do quotient rule and product rule. Can I simplify before I take a derivative? Yes, I can multiply 3x plus 2 times x to the negative 5th plus 1. And I promise you, it will make life a lot simpler. If you don't, then it's going to suck really bad, okay? Because then you're going to get into, oh, I got to use product rule. So the derivative of the first times the second plus the derivative of the second times the first. But when you do the derivative of the first, you're going to have to use what? Quotient rule. So you're going to have a quotient rule inside of the product rule.
Can you just toss that x up there?
So, you could. You can do it that way. That's one way to simplify it. What?
Is it okay to find, or you use the quotient rule on the first term and then just plug that into the product rule, or can you not take the derivative times the quotient?
So if you did, this would be you. If you don't simplify, this is what it would look like in the first step. I'm just going to show you the first step, and then I'll go back and do it the other way because this way is about to suck. Okay, so if I do it, product rule says derivative of the first. Well, when you do the derivative first, what do you got to use? So this is what it looked like. Derivative quotient rule is the derivative of the what? Top times the bottom minus the derivative of the bottom times the top. Actually, this might not be that bad. Over the bottom squared. But that was just the derivative of the first in the product rule.
So go with the second.
Now you got to go times the second. Yeah, it still sucks. Plus the derivative of the second which would be negative 5x to the what?
6.
Negative 6, thank you. What was I smoking? Times what? That's what it looks like. It's not terrible, it's just not great. It's kind of one of those, eh. Okay? Alright. So, how many of you want to simplify this? No thanks. Okay, so I'm not going to do it that way. I'm going to be smart about this, and I'm going to simplify it before I get started and go ahead and just FOIL the top. Or, what was really brilliant, you actually could get out of all of it. Okay? Mason has the best idea. FOIL the top, move the x to the top, multiply it out, and just use simple power rule. Okay, so technically what you could do is move the x to the top. If I move the x to the top, it'll become x to the what? Negative 1 times 3x plus 2 times x to the negative 5 plus 1. I'll FOIL first. So I'm going to have x to the negative 1. What are you going to get when you FOIL this?
3x.
Yeah, you add your exponents, so it'd be 3x to the negative 4, then plus 3x plus 2x to the negative 5 plus 2. Then what can you do?
It's true.
Multiply through by the x. This makes it a lot easier. So it'd be 3x to the what? Negative 5 plus.
Be 3.
It'd just be 3, wouldn't it? That's cool. That'd just be plus 3. Because when you add the exponents there, you get x to the 0. Anything to the 0 power is what? 1 plus 2x to the what? Negative 6 plus 2x to the negative 1. I like this. Now it's simple power rule. Now you go y prime. I got out of quotient rule. I got out of product rule. I didn't have to do any of that mess. So then you're going to get negative 15x to the negative 6. Derivative of constant 0 minus 12x to the negative 7 minus 2x to the negative 2. Now, to probably get the same answer that you would have gotten using product and quotient rule, product and quotient rule will probably somehow get a common denominator. So what you would do to simplify this, if you had to look for the answer, now you're dictated by what the multiple choice does. So if you see it right away and you're like, sweet, there's no common denominator, and you see this answer, awesome. But if you don't, what are you going to have to do? Yeah, you're going to have to get a common denominator, which is not really that difficult. What's the common denominator? So we'll put it all over x to the 7th. This needs an x, right? So that would be negative 15x. This one needs nothing. This one needs a... So this answer or this answer is correct. It's just you got to see which one they want. Okay? Helpful? So that is the derivative. What else? Got 16 more minutes and I'm stopping. Thank you. What else? There's nothing else from any of that homework. You got it all done and I'm going to be able to check it today at class. 28 is the same thing. Figure out how you can get out of quadrant. Or is it not?
Can you get out of this?
If you multiply the tops out, you can at least get it down the quotient rule. I don't know if you can go.
Oh, man.
Are you really bringing that for us?
Yeah. Yeah.
You want? Here, come have some. Oh my, you're such a good man.
He's a real MVP.
If there's any chocolate left over, bring it back.
Yeah.
You're welcome. You guys.
Oh gosh, man, we are gonna get out. Holy cow! I just look at something that goes through my hips. Okay. All right. How about what else?
Riley, bring up box of the light back here.
Hold on one second.
No chocolate. No chocolate. No